Okay, hello everyone. Another lecture video for CPSC 1012. In this video, I'm going to introduce working with methods in C Sharp. The objectives for the lesson will be to declare methods in C Sharp. So we'll look at how to declare any type of method that we might want to include in our solution. And then, of course, once we've declared the method, we'll look at how to go about calling the method to put it into use in our program. And then there are two additional concepts that I want to talk about, and I think we can include them here in this single lecture, and that is the refactoring of an existing solution. So we'll talk a little bit about what refactoring could look like and what that means, specifically about methods and extracting methods from our existing solutions. And then the final piece there will be the topic of overloading a method in C Sharp. So we'll briefly look at what overloading a method would look like and why you might want to use it or how it may be useful. And then also just explore this idea that we've in fact already been using overloaded methods from the very start of this program, even though we likely haven't really thought about it too much. So that's what we're going to cover over the next, hopefully less than an hour. We'll see how this goes. All right, let's get it. So what I'm working on here, you can see on the screen, is an existing solution that we've already walked through. So I've got two screens or two windows open here. One of them is the Method Problems 2 worksheet that you can find on the class Moodle site. And then the second window here is the planning document that we had kind of worked through for the if-else decision-making lecture video. So if you haven't already gone through that video and created the solution, I recommend you do that first. But if you've already gone through that and have the solution for taxable income ready, then you're ready to go with this one. So again, I like to use the existing problem exercises as kind of an introduction to the exercise worksheets, but also as a means to say, hey, like this is how you can approach these types of problems on your own. So in Method Problems 2, there are a sequence of 3 questions that are put to us here, and they're related, okay? And so the question that is being used here is one that I walked through in a live session with everyone a week ago. So if you have that solution for the ticket price, you could walk through this a bit easier than if you didn't, but you'd want to complete that exercise first to do these questions the way they're laid out. But what I'm going to do is just apply the same type of idea from what's presented here in questions 1 and 2 and 3 to our existing taxable income solution so we can see what that looks like. And yes, the walkthrough here is going to be one of creating a brand new method and seeing how we could use that in our solution, and then creating a method that in fact uses one of our existing methods. And I want to show you how you can embed methods or compose more complex methods by combining multiple smaller, simpler methods. And then the third piece will be the refactoring of the existing solution so that we look at some of the logic that's happening here. In this case, the determination of what the tax should be for a particular taxable income, and then returning that from a method. And I'll show you how we can take our existing code and use Visual Studio to help us extract methods out of the code. The overloading piece, I think will tie into the first 2 methods, the prompting methods that we had, and again, more just as a way to demonstrate, this is how you could do it. Later on, when there are better or more explicit reasons to overload a method, we can cover that again in future lectures. So hopefully you've gone through the lesson already and the readings for this section. I'm going to keep the theory to a minimum and just focus more on the application and the implementation of the topics in the solution we have. So the first thing we're being tasked with here is to create a helper function that can be used to prompt the user for input. Okay, and then it says here create a function, string prompt, and takes in a parameter label, which is a type string. And then it tells us the function here should display the label to the user, and then it should return the string that they enter. So we're just basically what we have seen already in our pseudocode solutions, where I'm just saying here, prompt, here's the label to display, and then what are we reading into taxable income. Basically, we're taking that and just kind of formalizing it into a method call that we could use within our actual code. So for example, if we go and revisit the existing solution, oops, we can see here our prompt to the user isn't really an explicit prompt. It's really just two statements that we've kind of thrown in the code that together combined act as a prompt for the user. And in this solution, it's not so bad. We only prompt for one input, but as you know, you've already worked on several programs now where we may prompt the user for multiple pieces of input. And as the programs we create become a little bit more complex, we're going to be doing more prompting for input from the user. And it might be in our interest to reduce this, it's not complex, but reduce these two statement prompts into a single method call so that we can kind of do away with some of the repeated code. Every time we prompt the user, for example, we're console.write and we're using a console.read line. In some cases, we're doing a parse, but one of the benefits of modules and modularization of programs is to reuse code. And so that would be a good use of that. We can reuse, a console.write and a console.read line and these two statements in multiple places. Effectively, we would reduce these two statements to one, which again, if you're prompting a user for 5 or 6 different things throughout your program, adds up to, multiple lines of savings and less complexity, because we can look at debugging and finding errors within just the method itself and not in our program everywhere we may have mistyped something for a prompt. So that's kind of the idea for the first bit. And it's pretty straightforward. We could go into here and create a plan for it, or you might decide to just try and implement it directly in the code. But I do want to show you something here within the planning phase that would be applicable to your future applications that you want to create for methods. So again, if you were just utilizing something like pseudocode, you could just define it as a function or a module or even a method. Again, I don't really care as far as planning is concerned. In your planning documentation, that's really for you. And like I said, for me, if you want to bring your plans to me and have a discussion about it. So there's no hard and fast rules about creating these planning documents. Just be sure that they're clear and easy to understand. So I like, for example, the terms functions or procedures in my planning. Again, depending on the language that you use to implement, they may be referred to as something else. They may be modules, submodules, procedures, functions, methods. Those names are in large part interchangeable or synonymous. And, in C# we talk about implementing methods. But as far as a basic plan goes, there's no reason why we couldn't just talk about, modules or functions. They all kind of mean the same thing. So I indicate that I'm creating or declaring some kind of a function by using what I use as my keyword function for my planning. I give it some kind of a name, and then I indicate the parameter list. So what does the method or the function expect to come in order for it to work? And in this case, I'm looking for a label as a string. So you have to, in order to use this prompt function, you've got to provide a string label. And then I'll just say here returns string. Okay. And then when I'm finishing my function, I'll just use some text like end function. So this is how I can define a function as far as my planning is concerned. And right away you can see the benefit of doing this, breaking your larger problem into smaller ones. If all I'm doing is focusing on the problem of how am I going to prompt the user, I don't really care about all this, right? The actual context of the program I'm creating goes away, and now I can just zero in on and focus on, well, how am I going to prompt the user? I've completely pulled this small problem out of the larger problem that I'm working on, and I can just focus on it. And I could focus on this while another developer is focusing on some other function. We can share the work, all of those benefits that come into play when we start modularizing our solutions. And so when we start to think about, well, what would this module look like to prompt the user? Again, we were given some explicit direction here that it should display the label and then return a string that the user enters. So we could just, do something like that. So we could, again, this is just planning, so it doesn't have to be specific, but we could do something like using the same code that we had from before. So we may do something like, prompt, and we're going to display the label, and then I'm going to read that into some variable. So right now, I don't have a variable that I could use for that. So if we want it to be explicit, we could do something like declare, let's call it input, and that's as a string. And then we would prompt, show our label, and we would read the input value into our input variable. And then because this returns a string, we would need somewhere a return statement. So we could do something like return input. So as far as my pseudocode planning goes, this is my prompt function. Okay, so I have a name. I know that it returns a string. I know what the parameters are. So we pass in a label, its type string. We declared a local scoped variable. So input only exists inside this function. And again, looking at the planning the way we have it here, it should make sense that this variable input only exists here. I couldn't use input anywhere else. And so when you're declaring and working on your methods in C#, just remember that any variable identifiers you declare within your method, they only exist in that method. They can only be seen in that method. They can't then be seen outside somewhere else. You can kind of picture these methods or functions as kind of black boxes where all the stuff that happens inside them is inside. And if you're outside the box, you can't see anything that's going on in there, which if you think about it, makes a lot of sense. For example, when you call the console.writeLine method and you pass a string into that method, you don't know what happens inside the writeLine method, right? And in the large part, you don't care either. You just care that whatever string you passed is going to be written to the console. How it does it, what internal parameters and variables it uses, doesn't matter. I only care that it does what it says it's going to do. And that's exactly the approach that you should take when you're creating your own methods is, whatever you do inside your method is only inside the method. Outside, other methods that might call it, they don't need to know and they can't know. Doesn't matter. So we'll go ahead and we'll implement something like that. But this is a pretty simple function. Doesn't take a lot to implement. So let's go ahead and create this method in C# and then we'll call it. So to put this into use here, I've got function as a prompt, prompt as a function. To indicate that I'm using that here, I already have kind of prompt. This would just be something like the following. So we would update it because it's now an assignment. We could say something like set the taxable income equal to, and now we're calling our prompt function and we're passing in this string. Okay, so that's how that would look, right? We're saying set taxable income, which is our local variable here, to our main program. We're going to assign it the value that got returned from prompt enter your taxable income. Now, the trick here, of course, is that our prompt function doesn't return a floating point value. It returns a string. So we could do some kind of like a typecast here or parse to just say something like, I'm going to call a function and prompt, but that returned value, I've got to convert that into a float before I can assign it to taxable income, right? And so again, in terms of my planning, that's clear to me. I can see how I'm using the method. I can see what I need to do with the result. How I implement that becomes a problem for, the actual coding piece. So let's take this now, these updates with our new function and the calling of that function and apply it to our C# in the form of a method. Okay, some base ground rules here before we get going. Everything that we're creating so far in our programs, if you have a look closely, already exists inside a method. Okay, so now we're starting to get and learn about the terminology that we can apply to what we've already been using for the last, however many weeks. So we have a class, in this case it's called our program. So everything for our program to this point exists inside this program class. And we have a main method, which is exactly what it sounds like. It is the main method that starts off our program. So when we execute a C# program, it's going to be looking for a main method in some kind of a default class. And so that's how that works. And now we have some language to use to describe this, right? It is a class or a static method as indicated by the keyword static here. Again, that means we don't need to instantiate or create an object in order to call that method. We'll talk more about class versus instance methods in a couple of weeks when we cover object-oriented programming in a little more detail. We then have the return type. So the main method doesn't return anything, which kind of makes sense. It's the place where your program begins. So there wouldn't really be another method to return a value to. So it returns nothing. We have the name, it's main, and then we have here a parameter list, which is an array of strings called args. And we'll be talking about arrays in the next topic. So this, you've already been working with methods. You've already been, it's granted, it's scaffolded for you, so we haven't had to type this out ourselves, but that's all this is. It's just a method. It's the main method. It has a little bit of special capabilities in terms of how we use it, but there's nothing fancy about it. It is just a method at the end of the day. And so when we declare additional methods, like now we want to create our prompt method, that method has to exist again within the class, right? And that has something to do with scope and visibility. We want from inside our main method to be able to send a call to our new prompt method that we're going to create. And so we have to be able to see that method from here. We're not going to be declaring, and you can't in this case, declare methods inside of other methods. So what we need to do is just make sure that we're declaring them all within the same class, okay? So this will now be the first code that we will type in that is outside of the main method. So don't feel like you're doing something wrong. This is accepted and is necessary, and you'll get more comfortable with it the more methods that we start to create in solutions and practice problems. It doesn't matter the placement. So the main method could appear at the top and then your supplemental methods could appear below. Some people like that approach because then the main method, the actual program, is what you see first, and then you could scroll down to see the additional user created or developer created methods. And other people like to declare all their methods up top and then the main at the very bottom. So you see everything that's included, and then at the very bottom you'll see it all put together in the main method. I don't necessarily have a preference for one or the other in C# anyway. In some other languages I code in, I like to declare methods that I'm going to use above, so I see everything, so my main would be at the bottom, but it doesn't really matter. For the sake of kind of, I would say, what's out there, we'll just declare it after the main method. So here's my main. Here's the scope for the main method. It begins here on line 15, and it ends down here on line 47, and you can see that on the pop-up. This ends static void main. So right after this line, this is where I want to create our new method. Okay, so let me just make a little additional space. So at this position here, we want to begin declaring the method signature. So again, it's going to be a static method because that's all we know about at this point. The return type is going to be string, and the name is going to be prompt. Okay, and then we include our parameter list. We know there's going to be a single parameter. It's called label in this example. And right now we're getting this little red squiggly because we've said in the signature that this method returns a string. And right now the method body doesn't return anything. So it says here, not all code paths return a value, right? So, which isn't great. So that'll go away as soon as we fix it. If we look at our plan, we declared input as a string. We then display the label, and then input stores the value from the user, and then we return that. So we can model that here as well. So we can declare a local input variable. We can do a console, we can do a console.write, the way that we've always been displaying our prompts. And then what we need to do after that is store value and input. So input is going to be assigned whatever we get from the console read line. And then lastly, we need to say, okay, we got the value, but this method needs to return that input. Okay, and so the red squiggly line goes away, and now we have a method. And that's it. So we've declared our prompt method. We haven't called it. We're not using it, so nothing is going to happen, but it's fine. It's just kind of sitting there available for use if and when we decide we want to put it into use. Now, what I would like to also see, and this is best practice, is to include comments that we can use to describe the methods that we create. So after you go ahead and declare a method in this course, what you want to do is immediately after go the line just above the method signature. And again, if you put in those 3 slashes to create a documentation comment, the Visual Studio IDE will put in some tags that you can use to properly document this method. Okay, and that's a best practice that I'm going to expect for all of your programs that you submit to me going forward that include methods. So the summary here is just a description of what the method does. So we can say something here like it prompts the user for input. Okay, that's a very generic or simple description. There is a parameter named label. We can describe that here. We can say this is the label. Oops. We'll say to display to the user. And then it returns the user input as a string. Okay, again, just descriptive stuff. So that's, now we have our method. And if you hover over this, you'll notice I have a spelling error, so that's it's good to fix. So prompts the user for input. If you hover over the name now, all of a sudden in the pop-up, you get not only the signature, which tells us a lot about how it works, right? So we know how to call it, we know what it returns, but it also shows us the details of our comment. So you'll see here, prompts the user for input. Oh, perfect. So that this comment isn't just, for us to read through the code. It's also useful for when we want to put this method to use, and then we could, get some pop-up information wherever we happen to call that method in our code. Okay, so I'm going to save that. So this now is a full and proper method declaration. Again, we could have shortcut some of this stuff here. So for example, the input isn't really necessary. We could just straight away do the write of the label, and then instead of input is assigned console.readline, we could have just said here return console.readline. But I'll leave it like that now just because it maps onto the planning. And I'll show you in a moment, again, after we put it to use, how once we've kind of modularized this code, we can make changes to the code without having an impact. As long as we're not changing the signature, we can change the internals of the method body without having an impact on any other code that makes use of it. So you could always add some efficiency or maintainability after the fact. You could just get a solution that works, kind of ship it, and then come back and refine it later on. So where we want to use this method, then we need to go back into the method where we want to call this, which is our main method, and identify where we want this to happen. So in this example, here's where we're prompting for input. We still want taxable income as a double, so we still need this double.parse call. But instead of double.parse and first preceding with a write and then a read line, our prompt method is going to return the string that the user entered. Well, that's what console.readline is doing right now. It's just that we have to first of all do a write. So we can replace this. We can now take this string. This becomes the label. Okay, this is the label that we want to show the user to kind of prompt them for input. So I'm going to highlight and cut that, Control X, and then I'm going to get rid of this. I don't need the console.write anymore. And taxable income is not going to be a direct parse on the read line. It's going to be a parse on our prompt function. And so I'm going to paste that string in there. And there we go. So I've just by, in this case, it seems like, well, we created, a method, and there's a whole pile of additional lines in there. And all we did was save ourselves, one line. But if we had 5 or 6 or 7 prompts all throughout our program, by creating this method, we've now reduced, however many prompts there were. If there were 7, we've now removed 7 lines of code. And we were able to reuse this prompt method any other place that we want to do our prompting. So that's it. We've now declared a method, right? We've talked a little bit about that, and we've now put our method call in to the main so that we could put it to use. So let's just see how this is going to work for us. So I'm going to run this program, and we should see that everything kind of runs just as expected. So we enter some taxable income, and we get the result. So nothing's changed. Everything still works. From the user's perspective, it's the same program. Nothing has gone differently. But internally, we've made some pretty simple modifications. Okay. So that at the core is a method declaration and a call. So everything going forward from this point now is really just more about how we can work with methods and do some additional things with them. But the meat and potatoes of declaring and calling a method has been demonstrated here in this simple example to this point. Okay, so the next thing that we're tasked to do in this, and this is where I want to show you how we can create methods that are composed of methods, is to create it says here, create a second helper that can be used to prompt the user for integer input. Okay, now in our solution, we're not looking for an integer, we're looking for a double. So we'll apply that to this particular problem. And so we don't have to do the double dot parse here. We'll create another method that will allow us to prompt for a double, and we can just call that. So we'll call prompt for double, and we'll pass in the label, and we'll have, basically the double dot parse piece of it will be hidden inside of that method. So let's scroll down here. Again, we've already got our prompt method. I'm going to create this prompt for double after our prompt method. So again, still inside the class program scope, make sure that it's not outside. If you create your method out here, you're going to get red squiggly lines all over. There's going to be problems. Okay, so make sure when you're declaring your methods again that you're inside the class scope. For now, they're all going to be static methods. These are class methods. And this method is going to return a double. Okay, I'm going to name it prompt for double. And again, this is going to be taking in a parameter, which is a label. And this is going to run exactly the same way that we had just done the previous, except for the fact that instead of doing a return of a string, which is just the console.readline, we want to try to do a double dot parse. Okay, we're not going to do any exception handling in this method because I don't want to handle the exceptions here. I want to allow the calling method to deal with exceptions in whatever way they want to do it. So all we need to do is just wrap everything up. And as you can see here, again, like we saw when we first started with the prompt method, we have this red squiggly underline because prompt for double doesn't return a value. So that'll go away as soon as we correct for that. So we can do something similar. We can declare double. I'll call it input. And at some point, we're going to want to return input. Okay. I'm skipping the planning piece because I think you get the point. It's pretty similar. Now, the one thing I want to show you here is we could copy and paste and do this same thing over again and say, okay, console.write, and then input is double.parse console.readline. But since what we're doing here is just prompting again and really just taking the input value and parsing it, we can, inside our prompt for double method, make use of the prompt method. So we could do something like input is assigned, and then let's just call that prompt method and pass the label on there. Okay, and now it's going to complain because prompt returns a string, and a string can't be stored in our double input. So we just do the input, the double dot parse on this prompt call. Okay, I'm going to pause here for a moment just so you can let this sink in. The prompt for double method, when it's called, accepts a string label. Okay, and the label will be what we display to the user to prompt them for their input. Inside this method, we are going to parse a double from the returned value from this call to prompt. So we're taking the label that was passed in to the prompt for double. Remember, it gets copied as it's a string. And then we're going to take that same string and we're going to pass it on again to the prompt method, which is here. And so then that label got passed from here and there. It gets copied here. We'll display it. We'll read the user's input and we'll return it. That user input gets returned here from prompt, and then we parse it into a double, and then we return that double. Okay. Again, the cost savings, for utilizing the prompt method here is one line, but it's a savings, and I already have a method that prompts. So why would I reuse this code? Why would I copy and paste this code when it's already here? Okay. So instead of using these two lines, I'm just using one. I'm I have a prompt method. All I'm really doing here is saying go one step further and use that prompt, but also then parse the returned value, if you can, into a double. Okay. And so once we've completed that, we can go ahead here, 3 slashes. We could put in our comment. So we can say prompts the user for double input. Again, label is, the label to display to the user. And it returns the user, input as a double. Okay, we can save it. And so here again now, nothing is happening with this method. We haven't called it, so it's not used anywhere. It's fine. So we scroll back up to our main method where we were previously double.parsing our prompt. Well, we now have a prompt that takes care of that for us. So we can get rid of this piece. And instead of calling prompt, we can call prompt for double. And now we have a method that does that for us. And it simplifies things. Again, we have good meaningful names, so it makes sense because our comment is in below. When I hover over it, I know this prompts the user for double input. Oh, perfect. That's exactly what I want, right? I have a double variable. I want to prompt the user for a double input, so I'll call the prompt for double method. This is the string to show the user on the screen. So let's try something here. I'll set a breakpoint, and let's walk through this and see what happens. Okay, so we're stuck on this line. We're going to prompt for double. And so what we can do at this point, if we go back here, just hold on a moment, we can see here's our terminal window. So we're stuck right now because it's breaking on this line. So let's do a step into, okay? And if we step into, when we're debugging, that will go into the method call that we're on. Instead of completing it and stepping over, we want to go in. So you can see as soon as we did that, execution left the main method, and now we are in the prompt for double, okay? And if we look at our locals tab, we can see we have a label, which has this text, enter your taxable income. Remember, that is the argument that we passed in here. So this literal string argument was copied, and control has moved to the method and was copied here. So my label now has that literal string value. Input currently has, the default of 0 because we haven't done anything with it. And so here now we can do a step over. So now we're going to do an input is double parse, and we've got another call to prompt. So I'm going to do another step into, and we'll see that now execution is jumped one more time into the prompt method. And again, label here has the passed in value. Okay, the important thing to note here is this label is not the same as this label. They have the same name, but they are not the same. Okay, one way to think about it is if you treat each method declaration as kind of its own room, or like I said before, like a box, and inside the box, we don't know what's going on from outside. So here, when we call prompt and we pass in label, which is locally this variable, we're passing the value. So it was enter your taxable income. That's what got passed to prompt. It got copied to the local parameter inside the prompt method called label. But this could have been called anything. We could have called this X and called this Y, and this would still work. Okay, it's the values that are getting passed around. It's not the name of the parameter that's getting passed around. And if you think about it, it makes sense. I didn't pass in a variable called label here. I just passed in a literal string. Okay, so what matters is not the name of the parameters. What matters is the type. So it mattered that when I called prompt for double, I passed in a string, right? Here, we're going to refer to that passed in string as label. The same thing is true here. When we call prompt, it doesn't matter that we pass in something called label. What matters here is that we passed in a string. And so here, the string value of this label, which was enter your taxable income, got passed and copied to this parameter, which happens to be called label. And so here now we'll see it'll be written to the screen. So we'll step over. Okay, so it's written out to the screen. Now we're waiting for the user to input something. This is inside the prompt method. So we'll step over that. I'll enter my value. Okay, now we come back and you can see input is the string value 5, followed by some zeros. So we're going to return that. So if we step over this, execution is going to end, right? The prompt method is over, and we return now back to prompt for double. So this is done, and you can see here the string 50,000 is what's been returned. And now we're going to parse that into a double and assign it to input. So input is 0. We're going to take this returned 50,000 string and try to parse it. So we step over, and now input has the double value 50,000. So the parsing has ended, and now we can return that 50,000 as a double. So again, we step over. This method is ending because we're returning that value. So 50,000 will be returned. We're now finally going to return back to the main method, and 50,000 is going to be assigned to taxable income. So we step over, and now taxable income, if we look here, has that 50,000 value. Notice that the labels don't show up here. Again, labels, parameters that we defined in these methods only exist here. So when we're looking at variables that exist in our main method, we don't see them because they're not necessary. They don't exist in this scope, right? So just keep that in mind. When you're declaring your methods, whatever you're looking at is only local to the method. This string label only exists here. This string label only exists here. One does not impact the other. They are entirely different. What matters is when you make a call to a method that you pass in the appropriate type. So again, one final time. Here when we called prompt for double, we passed in a string. Perfect. That's what it expects. Okay? It doesn't expect it to be in a variable called label or anything like that. It just says if you call this, you need to give a string. Okay? Internally, this string is referred to as label, but I don't have to know about that here. And then the same thing is true in those method calls. And then so from this point on, now that we have that 50,000, the code will just execute as it always has. We can get rid of our breakpoint and resume. And we see that the tax due is X, whatever that happens to be. So that's how we can walk through, again, in the debugger to make sense of how these calls are being put together. But also, again, that yes, you can have your own methods call your own methods. There's no limit to how many methods you can call or nest the calls deep. Use them in whatever way makes the most sense. But now I've got a method that I can use to prompt for strings, and I've also got one that I can use to prompt for doubles. And what I want to show you here, just before we get into the refactoring piece, is this idea that now that we've kind of created the contract, right? The signature here tells any calling method exactly how to call the method, right? So the name and what we have to pass it, but also what to expect back. What we do inside here doesn't matter. So we can make changes to these methods without impacting how they're being used elsewhere. So like I mentioned before, we can really get rid of input. It's not necessary. We can just straight away display the label, and instead of storing input, we can just say here, well, whatever the user enters, just return it straight away. So take the label, write it to the console, and then return whatever they typed in here at the keyboard. I don't need the internal input variable. And if I save that, nothing has changed. I didn't want to play this. Saving and playing. Okay. If we make this change down here in prompt for double where we're calling prompt, nothing changes. Prompt still needs a string, and we're calling it and passing it a string. Whatever happened inside has no impact on the remaining modules or methods in this case that are using it. And so we could do the exact same thing here. This input is really kind of irrelevant. I don't need it. We can just straight away say return the parsed double value that we got from the string that returned from prompt. So we're saying call prompt, with passing the label we want to show, and the string that comes back from prompt, parse that into a double, and then return it. And that has no impact on what we're doing here, because this method says when you call it, pass in a string and it'll return a double. And that's still exactly what it does, but I don't have to make any changes here. So again, once you've got your methods in place, if you don't have to make changes to the signatures, then you can do whatever you want internally. You can make changes, improve them, right? Maybe there was a bug you found in a method, you need to go and update it. All you need to do is go to that method, update it, and then everywhere that you're using that method, everywhere that it's being called, will immediately reflect those changes without having to make updates elsewhere in your code. Okay, so that's one of the huge benefits, again, of working with methods or modules, is that you can, once you define the signature, you can work on the guts of it without having to worry about, well, what impact is this going to have on other methods? Well, none. So long as it does what it says, it takes a string and returns a string, you can do whatever you want inside. Okay, so that's a good kind of piece so far, right? Now this does nothing for exception handling. If we prompt the user and they type in something that's not a double, we're not catching anything. But again, that would just be something we could take care of here. We could use a do while and a try catch around this. Some of you I'd seen in previous assignments and practice were unsure of how to wrap the prompts, for example, inside the try catch. Well, this makes it really easy. Instead of having to split the console.write and then just maybe try catch around the parse piece, well, now it's just try catch around this one line. There's no two lines to split it, right? It's no longer a question of, do I group those two lines or don't I? Yeah, they're grouped necessarily because they're inside this method, and this method might throw an exception. So you try catch on the whole thing. So that'd be something for you to implement to update this, is see if you can get some exception handling in place now that we've got this new method that may throw an exception because the double. That we could include that in the comment as well, but let's take one step at a time. Okay, so we're doing pretty good for time. So that's declaring, using, and then composing methods of other methods. So the next thing I want to show you is this idea of refactoring. Okay, and refactoring is quite useful, and it can mean a number of different things. So oftentimes refactoring code really just means at a high level that you're taking existing code and you're making adjustments, right? Usually for the better. So it could be something like renaming a variable throughout your code. It could be extracting a method from a larger method, right? It could be extracting objects or classes. So what we're going to focus on right now is this idea that we might refactor this code so that it makes use of some additional methods. And I want to show you some simple ways to do that. Obviously the most simplest way is to just copy and paste existing code to other places, similar to what we had just done. But you can also use Visual Studio as a tool to help you extract methods and rename things as well. Okay, so we'll go through this and we'll extract a couple of them. The first one I want to show you will be very simple. Let's just work on a method that does nothing. It takes nothing and it returns nothing, and all it really does is just act as a placeholder. So in my previous plans working with you, I'm always using this idea of like display a program title, and so we could really treat that as its own separate module. I'm kind of treating it that way already. Without us talking about modules to this point, I've pretty much from the beginning said, look, I don't really care how this works, but just display some kind of a program title. And so we could do that with our code here. If we wanted to take this, maybe it was a bit more extravagant with instructions and who the developer was or something. And I said, I don't really care about seeing that in my main method. Let's remove that. Let's extract that out of the main method and put it into its own smaller method. That would be an example of refactoring our code. Okay, and so one way to do that would be to, again, just create another method for it. So at the end of the prompt for double, we might go ahead and create a static void display, I'll call it title. Okay, and display title doesn't take any parameters. We don't need to give it anything, and it's not going to return anything. When we call this method, it's just going to do a bunch of print statements, right? It's going to do console.writeLine or whatever, and that's it. So once we've created that signature, then we could take this code from here. We could cut it, and we could paste it. We could put our comment in, right? This displays the program title. And then up here where we had it already, we would just make a call to display title, okay? And so that is kind of the simplest form of refactoring that we can kind of look at in this case. We have an existing solution. We identify kind of a smaller task within the larger task, and we take that smaller task and we extract it out and plop it into its own method. Now, in this example, I'm not going to reuse that. I'm not calling display title anywhere else. But in some cases, I might. Maybe there's a reason to display the title in a loop or some other function or something like that. Maybe that's useful. Okay, so that's one method for creating or extracting or refactoring a method. So I'm going to just Control Z it here, Command Z it on my Mac to go back to a place in time where we didn't do this. Okay, so oh, no, that's not what I want to do at all. That's what I thought. There we go. Okay, so another thing we can do, if we go back in time here, is Visual Studio is pretty keen. So I'm in my Mac. It's a little bit different, but on Windows, you have the same functionality. In the Moodle course page, there should be a link to a short little how-to for refactoring on Visual Studio and Windows. But if you highlight your code, and this is, again, very similar to the Windows version of Visual Studio, I've got this option to do a quick fix. On Windows, I think straight away it's something like refactor. But if I choose a quick fix, I get a couple of options, and one of them is to just extract a method. And so if I hover over that for a moment, it shows you exactly what that's going to do, which if you look closely is almost identical to what I've just done. Okay, in the red boxes, we can see it's showing us the lines that are going to be removed, and then we got a green highlighted line. That'll be the new line that goes in. And so by default, it's just going to call this new method, but we can change it to display title or whatever we want. And then down below, you can see the green impact where the new method declaration is going to be put in place. And there it says private static void, and private is a visibility specifier, which we haven't talked about. We don't need to talk about it yet, but for now it's fine. So this is a really quick way to extract methods. Rather than cutting and pasting and creating them on your own, you could just highlight the code, choose the refactor or quick fix, and then extract a method, and then it goes ahead and does that for you. So now I just type in display title and hit enter. And so now my display title method call is there, and my declaration is down here. All I'm going to do is get rid of the private because I don't need that. But that's kind of a simple way of creating methods or extracting and refactoring methods out of your existing solutions. So I'm just going to say here, this displays the program title. It doesn't really do a whole bunch. That's that. If you're going to refactor larger chunks of code, that's also possible. So again, if we look at what the question here was asking for this ticket calculation or ticket determination problem, it says create a method called ticket price that takes in the option and then returns the price, whatever. So we can do the same kind of idea. It says also use a display menu, but we don't have a menu for ours. So we can apply that same functionality to our solution, where we basically this tax due, that's what we're calculating. We may want to use a method to determine the tax due. And this is the decision structure that we use to determine, based on the tax due, how much it is. Now, the other thing that's important to note here is my current solution, the way I have it, has a number of constants that are also used as part of the solution. So these constants will need to make their way into the method. And one additional change I'd like to make here before we do that is I've updated everything here so that we have kind of constants in place. So if we make changes to any of these rates, they're automatically reflected in the calculations. But one of them that's not taken into account are the tax 1 and tax 2 bracket amounts that get added to tax 2 and tax 3 respectively. So if I were, for example, to change the first tax bracket rate to 0.6 or 0.06, this would no longer be accurate. I would have to manually change this. And again, I'm lazy and I don't want to have to make multiple changes. If we change the first tax bracket rate, I just want this to reflect that rate. Okay, and so I know that this is just the result of taking the the first bracket value and multiplying it by the first bracket rate. So I'm just going to replace the 2,500 with that here. So we take our first bracket limit and we multiply that by the first bracket rate. That'll give us the 2,500. And then I'm going to do the same thing here. I want my second bracket limit multiplied by my second bracket, by my second bracket rate. Okay, and if you wanted to be explicit, we could surround that in parentheses to indicate that, hey, this is like, the second bracket tax that you would pay. This is the first bracket tax that you would pay, and save that. So now I no longer have to worry about, kind of froze up here. I don't have to worry about, making changes up here that are going to impact code that I have to change somewhere else. That's, again, more of a maintainability issue, but is important to identify. So now that I've got those changes, what I'm going to do is I'm going to highlight these lines of code. We'll try the same thing. I'll do a quick fix. And again, I'd like to extract a method. Okay, again, we get a pop-up here that shows us what's going to go on. So, right, some indication we're going to get tax due is assigned, and then it's got a new method. And you'll notice here it's trying to pass all those things in. Okay, so there's no way for me to kind of get up there. But if you have a look, it says tax due is assigned, new method, and then it's taxable income, and then comma, first bracket, second bracket, first, et cetera, which is all kind of fine, whatever. And then the method signature for this new method is going to include all of those pieces. And so, anyways, we could decide that's worth it or not worth it. I'm going to just leave them inside the new method. I don't really need them in the main anymore, but we can see how that's going to work. So, right, there's also an option here to extract a local function, but it doesn't really matter. Okay, so we'll extract a method, and bang, there we go. So the new method, I want it to be called get tax due, or it could be calculate tax due, whatever you want to call it. That's fine. You notice our main method now is shrunk up. It's very small, and it also becomes very easy to read. So our main method says, here's some variables, display a title. The tax due is get the tax due, and then we just write line, taxable income and tax due. It's very simple, right? Even the prompt for double is here. It's very, very short and sweet. We got rid of all the details. But what I'm going to do is I'm going to modify this. I only want to pass in the taxable income. These constants don't have any meaning anymore inside the main. So I'm going to just cut this here and delete all that. So it's tax due is assigned. We call get tax due. We just pass the taxable income. And I'm going to cut and paste these constants into my method. Okay, and then we can update our signature here as well. So the IDE did a lot of the work for us. We might have to make some updates in some cases. In other cases, we don't have to make any. But now this works. Okay, so we get rid of, again, the private keyword. I don't care about that. And now we can put in our comment. So this, I'll say, calculates the taxes due based on taxable income. Right, so that's the description. The parameter is kind of what way it is the taxable income. There's not really much more to say about that. And then finally, it returns the tax, or I'll say the amount of taxes due. Okay, it's fine. And that's it. So now we've got even kind of the guts of that problem, right? Our program now is just get tax due. Like, I don't care where this comes from. This could have been read in from a file. So maybe we had a file of records, and every record has a client's first name, last name, and their taxable income. And for every record we read in from the file, we want to get the taxes that they owe. Okay, this method doesn't care where that taxable income comes from. Whereas before, our program was very rigid, right? It had to come from the user, from the prompt. That's the only way the program worked. But now that we've extracted just this simple method, we only have to deal with the method in terms of its signature. So as long as we have a taxable income value, we can get the taxes due for that value. It doesn't matter where this comes from. So again, we've got this added flexibility by modularizing our solution. Okay, and then also the main method becomes very simple to parse and make sense of. So there's not much here. Our main method goes as follows. We have a taxable income and tax due. Those are the variables for this program. We display a title. The taxable income, we prompt for a double from the user. This is the label. We say enter your taxable income. And then we get the tax due. We pass the taxable income. It gets stored here. And then we display it. Our main method, I would argue, is much more readable, easier to make sense of at this kind of high level view. And we've kind of pushed all the details out into these smaller methods, right? So that would be an example of this, of like a top-down approach where we have a larger problem and we just try to figure out the generalities, right? So what are the generalities of this problem? Well, we have to display a title. We've got to get the amount of tax income they had. We're going to have to, figure out how much taxes they owe and then display it. And so now my main method really reads as like this kind of just general solution. And then from there, we go down and start implementing the details in these smaller methods. So that's an approach, again, that it doesn't sit well with everyone, but a lot of people do think that way. They're able to come up with a high-level, kind of solution and then break it down into the smaller details. And that would be an example of a top-down solution. And then within each of these individual methods, now we have to start thinking about, okay, well, what are the things that we know about? We know about data types. We know about method calls and displaying and parsing. So we take all those small, fine details and we put them together, right? If-else structures. We put them together to build up to the solution that we have now in the form of this smaller method. So we're using both a top-down approach and also a bottom-up, as is mentioned in the lesson. Or oftentimes, it's neither one or the other. To build a full solution, we often have to use a little bit of both. Okay, so that original solution that we had was fine. It worked, but now we were able to take it and break it up into smaller modules and still put them all back up together so that we have a meaningful solution at the end of the day. And that's kind of, again, for this course anyway, in programming fundamentals, that's kind of the meat and potatoes of working with methods. There is another piece here that has to do with this idea of method overloading. And again, I just want to talk to you briefly about that. If we have an explicit need for overloading methods, that'll come up later in the object-oriented section of the course. But the idea of method overloading is just one where you have the same method name, but it can be called and be passed different arguments, okay? And so it's possible for us to do that too. That what distinguishes an overloaded method from another one is, again, that you've got effectively the same method declared twice, but with different method signatures, okay? And you might think, well, how does that happen? Really how it happens is you have different parameter lists, okay? So for example, let's say, let's look at console.write, for example, okay? Or even WriteLine, it doesn't matter. So here we've got WriteLine, and you'll see it's taking in a string, or it specifies here that console.WriteLine has a string parameter. But then you'll see beside that, it says here plus 17 overloads, okay? And you might ask yourself, well, what does that mean? And that means that this method has essentially been declared 17 plus 1, 18 times to allow for it to be called with different arguments. Okay, and so in this example, we're calling it and passing it in a string. But if we were to call WriteLine and pass in, let's say, an int value, and now we look at this, you'll see that this says console.WriteLine int plus 17 overloads. It says it writes the text representation of the specified 32-bit signed int value. Whereas here on the strings, it says it writes the specified string value. If we change this int to a double, you'll see now the change again. So now it's a WriteLine with a double. And it says here it writes the text representation of the specified double. So WriteLine is the perfect example of an overloaded method. It's the same name, but depending on the arguments that are passed in, a different version of that or overloaded version of that method gets called. So if we wanted to have different prompts, like for example, maybe we have a prompt that accepts a string, and maybe we also have a prompt that accepts a string label, but maybe also some kind of an error message or something, we could still reuse this name, but specify comma, an additional argument. Or if we had prompt that didn't just take in a string, maybe the prompt could take in an integer or double. We could redefine this method with the same name, but then just update the parameter list. Okay, and so that's what method overloading is. Again, we've already been using it. We just haven't implemented it in our own solutions. And like I said, it'll make more sense for us to start looking at method overloading in more detail when we start to explore some more of the object-oriented principles and practices later on in this course. So for now, that's that. Again, I hope you found that informative. I try to stick to the point and not ramble on too much. So if you do have any questions about methods, declaring them, calling them, or anything that's happened in this lecture, please be sure to reach out to your instructor. Send all your questions in, and if you need to interact with them or get some more hands-on one-on-one time, that should be possible too. So until next time, we'll see you later.